Hello, happy Sunday. Sunday where I am, but happy whatever day of the week it is wherever you are. I hope you're doing well and keeping well. So today I thought I'd do a quick demonstration to sort of get the focus on the big thing in AI that people aren't really seeing. They're so focused on AI IDEs and AI development that they're missing the big picture in development. It's not about AI writing code. It's about clever consumption, meaning that you need to write little code in the first place and using AI to do that. People aren't really seeing that. It's going to be the big thing you're going to be seeing shortly. So I thought I'd give you a demonstration of that. It's always easier to understand something if you see it, to understand what somebody is saying. So that's what I thought I'd do today. So that is my plan for today. So what I'm going to do today is I've very much I've built my own orchestrator over time, and I've had capabilities in there which weren't available. So before chain of thought was a thing in models, I'd already read papers about chain of thought, and I used out of inference chain of thought. And in fact, even though reasoning is built into some models now, you pay for the inference and you pay for the cost of doing it. And actually outside of inference chain of thought, so basically multiple agent orchestrations, to take a task, to plan a task, and you're seeing planners coming into all the frameworks now to be able to do this. You break it down into smaller tasks, you split those into subtasks, you give to a model, because it gives a model a better chance of coming out with a better outcome and not getting distracted and giving you poorer results. So I've used outside, so that wasn't available, so I had my own orchestrator to do that. It's now become available with reasoning models. Now, also, one of the things that I've utilized is before function calling, I have this concept of limbs. So to be able to allow AI to be able to call external APIs, external compute functions to be able to do things. So function calling is now something which is built into a lot of these sort of orchestration frameworks. They still don't do as much as what I can do these days, so I still might mix and match my own stuff, and that's what you can do with this. You can mix and match these, so you're not locked into a particular framework. You can use a framework for its best capabilities to do certain things. So I've certainly been doing that, and I probably will continue to do that, because my limbs can do things like agents can actually dialogue between each other as part of a flow, or an agent can spin up multiple other agents that it will talk to during a conversation as part of an orchestration to be able to reach an outcome that will just be subsidiary agents that will only last for the lifetime of that master agent's particular remit to complete its task, but are available to it to do things. And it can go away and talk to these over an elastic bus, so they can be on different pieces of compute, and it can go away and fully control remote compute and issue commands to remote compute to do things, so that it can basically scale itself to do tasks like development, for example. Those aren't currently in function calling, but what you can do with function calling is actually quite powerful. So I'll give you a demonstration of that, how easy it is to do, how little code it is, and how by just being clever about your consumption, you can save yourself a lot of development time. The third demonstration I'll show you is structured output. So again, from day one, I've always been using JSON quite strongly for machine-to-machine agents. I've always seen machine-to-machine agents as actually the most powerful paradigm in agentic flows, and we're starting to see that now. It's becoming more common. And for machines to be able to react to things that come out of models, it needs to be a machine-friendly format. Generally, that's going to be something like JSON. So I've used JSON for a long time. Historically, that's meant writing a prompt where a very wordy prompt where you give samples of the JSON and what is in each field, describe each field. And with structured outputs now, you can actually give it a contract of this is the JSON I want. So for example, you can give a model a prompt. You don't need in that prompt necessarily. You can augment it to, if there's ambiguity about the contract, to give more information about what some of those fields are. But you can then also give it just the JSON schema, and it will go and will police that you only get JSON. When you're doing that yourself, sometimes models will emit things that aren't JSON. So you have to reflect and check, did I get the expected JSON, or do I need to make it do it again? Do I need to sort of, just let it know that, hang on, that you're only meant to be emitting JSON? You don't need to do that with structured outputs. That's all built into the sort of framework of how they're generated. Now, actually building structured outputs, if you're making raw API calls, if you've seen these, they're quite arduous to build. There's a lot of fields that you need to define, even for a single field, to get a structured output JSON field. So some of these frameworks, by them doing it, and I've built my own to do that, my own orchestration, but with Semantic Kernel, it can do it for you out the box. So you can give it a type, you can specify that in the kernel sort of configuration, and then you'll only get something which gets cast to that particular JSON schema, an object in the case of C# that you can do stuff with later. So that's another thing we'll do. So I got to about 50 minutes when I'd done those. I had 10 minutes left. I thought, what are we going to do now? So I thought, okay, these are all text experiences. So these could be text experiences in a chatbot, or text experiences in some kind of UI that is integrated with other UI things going on. But how about we pivot it to voice? So how about, what if we wanted to use this using WebRTC inside a browser? Or what if we wanted to plug it into our telephony service? Am I going to have to rewrite all this code to do other things? So I added in an experience layer. So basically, this allows it to work in multiple modalities. So 2 for this demonstration. 10 minutes isn't a long time. So as well as text, I also added support for voice. And we'll see towards the end, we'll run one of those existing agents with no changes working in a voice modality. And in later demonstrations, I'm going to show you a lot more with what we're doing here. So with structured outputs, for example, if you define a JSON contract, then if you've got an existing API and that existing API is the JSON contract and you set things up right, then essentially you can have a second agent as part of the flow. So you can orchestrate agents, agent A to gather all the gathering and do function calling, agent B to go and send it to my API, to then be able to, and it may be a dumb agent, it may not actually have any inference in it. An agent doesn't necessarily have to be something using AI. It can actually be just basically a transit agent to go and do something else, send it to the endpoint. So if you've already got the JSON, you've already got an endpoint, then you don't need to write any new code to get that into your database. So I'll be showing you that. I'll also be showing how you can mix and match these frameworks. So if you've watched any of my demonstrations over the past couple of years, you've seen probably a good year ago now, I started showing you the sort of database agents that I've been building, so they can talk to SQL, NoSQL, GraphQL resources. And as part of that, I don't really want to configure them each time I connect to a different database. So they have capabilities to go and introspect the schema. So first of all, they'll build a model of the schema. Then they'll go away and look at the data, and they'll understand what the data is. And if there is ambiguity about some of the data, it will look at some of the data and figure out what it is. And it will build essentially its own prompt for proxying it. On top of that, you can add your own validation prompts for locking down where things go and what it has access to, what it doesn't. But we can certainly do that on the fly. So that's certainly something I'll be demonstrating at a later date when I've got a bit more time. And one of the things I'll use this demonstration to do actually is use that, say, we get the structured output, we get the JSON, we send it to an API, how you can use these agentic flows to actually bypass the perimeter of your existing security. And I'll show you a very simple demonstration of how we can do that. It's going to be a big, big thing when it first happens, but it's not only your software stack, you've not only got to worry about your software stack building these capabilities. All applications now are supporting agentic flows, and they have access to all kinds of data. So even third-party products you use can have these agentic flows in now that can do things, and you might integrate with them. And I did a discussion of basically model context protocol, which is basically the RESTful API of AI that allows you very much to connect different AI systems together very easily. There's all kinds of potential messages you can get yourself in there with what can happen with agents having access to things and doing things with them that you don't expect, or bad actors getting access to those agents to be able to do things with them. So I'll be able to give you a very quick demonstration of that as well, sort of in the future. So today it's all about doing something in an hour. Multiple things. How much can you do in an hour? And I think you'll find you can do a lot. How much code did I have to write? Not a lot. So that's the message here. It's not about IDEs writing lots of code. That is not what we're talking about here. We're talking about something completely different. So the best thing to do is let's start firing up these demos, and then as I go through each demo, I'll talk you through how they work, and then we can hopefully you'll get a better picture of what I mean by consumption actually is key, not writing code. So what we've got here, so I've written, there's about 5 projects here, some application, infrastructure, domain stuff. We've got a C# console that's connected to it. We've got some DI here just to set a few things up that are used via the actual console. And then inside of the infrastructure layer, we've got all the infrastructure sort of DI set up for things. So you can see in here, we've got this thing like a credit service and a telephony service. That's used by the function calling demo. We've also got one very simple chat agent interface that's used for all 3 demonstrations here. So basically we've got a factory here so that we get the concrete types for the different types of things related to that one common interface, so that we can use DI to nicely sort of marry them all up. So that's what we're going to do. So the first thing to do, I think, is let's just do a demonstration, and then I'll talk you through what it's actually showing us. So let's fire up the console. So we've got the console going here. So this is set up to run either the chat function or structured output demo, and also set up to run in text or voice modalities. So we're going to run it in text to start with, and then at the end I'll just very quickly give you a demo of how I very quickly pivoted this into also a voice modality. Later on I'll show you how I'll pivot this into UI experiences using the same code without rewriting the code. That'll be a later demo. So let's first start with the chat experience. So let's fire up chat. So this is basically set up as a complaint agent, and this has no complex functionality at the end. It's got a 2-sentence prompt to tell it what it needs to gather. It'll gather the conversation, it'll go away, and then you'll probably do what you're doing elsewhere. You'll either get a model to run against that and stick something somewhere, or you run some code to do that. So let's start off our complaint. So what information do you need? Mistyped information, but of course models know about that, so it's correctly inferred I meant information. So my name is John Smith. Sorry, I meant George Smith. So again, there's no rules or logic for us to define how this works. With a simple two-sentence prompt, these models are trained on sufficient things now. They've seen these things enough. They know what to do. I meant George. Okay, now it wants the delivery number, so I'm going to give it a delivery number. It was damaged. Yes, it was a TV with a cracked screen. No, I think we're done on that. Now, what we've got at the end here is this is basically the completion history that comes out of Semantic Kernel. And you can see in here, you can see messages that relate to content, whether it was a user or an assistant message. So at this point, that's all that's really done. That'll go away, and you'll either process that with another model as part of an agent orchestration, or you go and get some code to do something with that, maybe just log the complaint in a CRM system, whatever you want to do. So that's pretty much that demo. So now let's have a look at the code behind that before we continue. So this is the chat agent. So I've got some dependency injection here. I'm using my own little beautifier that I'm using that gave you that nice little formatted JSON at the end. I'm using this thing called the Experience Manager, which allows multiple modality on the same code. So I didn't need to rewrite the code. I built in the Experience Manager as part of the initial implementation. There was only one experience. I added a second experience at the end, which was voice. So that allows this to work in multiple modalities without rewriting the application. So it's very simple. So the first thing, you need the semantic kernel. There are other kernel packages you might need for different providers, for example, that you might need to include. So what we do is we basically create a kernel builder. In this builder, I've added what is already in the core, the OpenAI chat completion, which allows it to talk to OpenAI models. Now there are other ones for Llama, for other model types, Azure AI Foundry, for example, and they might be in the semantic kernel, or there may be a subsidiary package you need to install. So of course, for this purpose, I'll just use an OpenAI, but you've seen recently, and I've been demonstrating since day one again, model agnosticity, and you've started to see that now in Azure AI Foundry, for example. They've introduced a model router. So this is so you can actually route and select the criteria for which model I use. One, to use the best model for the best job. Another one, to control costs. So again, we're using very simple, very cheap models. We probably won't even use more than a couple of cents doing this whole demonstration, if that. So I could use one of the latest models. I don't need to. It's all about consumption. The model's got sufficiently to such a level, maybe a year ago, that there's a lot you can do with them if you control the context of a conversation and break tasks into smaller parts. And you're seeing that in all these orchestration platforms now. They're all building planners in there to do exactly that, and that makes perfect sense. The less you give a model in a big chunk, the more it's got a chance of coming out with a good outcome. So we build our kernel, which we do here. We tell it we want to use their chat completion service, and here we see the prompt. Now, for the purpose of the demonstration, I put the prompt in the code here so that we can see it, but we'd have a prompt manager in reality, so we could reuse this code for anything. But there's only 2 sentences there, which basically describes what it's got to do, and then it just sets an initial message. Again, you would have that as part of the setup of the constructor for doing this generally, to be able to do that, or an initialization method. And then essentially all it does is it goes away. It's all via the Experience Manager, so I can plug in a different modal experience later, because I knew I might want to do that. I wasn't sure if I was going to have time. And then once it goes away, calls a chat service using the kernel, passes the full history. So remember, these are stateless. So models, you have message 1 and it comes back with message 2. When you go again and ask message 3, it takes message 1, 2, and 3 and presses them all again from the start each time. Now that's changed slightly, and if you look at my model costing demonstration I did a few weeks ago, you'll see that I show there that actually there are sort of concepts coming in now, like prompt caching. Now, this what this basically does is it doesn't necessarily store the text on its own as a trigger to save cost. It does hash the text in field boundaries of known sizes, but it actually caches the transformation compute history that was used to get to that point of the inference. So it doesn't need to regenerate that from start. Now, that saves you money up to 50%, but also saves you latency 80 or 90%. And you'll see on that cost model, I actually talk about, well, actually, do you really want to use big context anyway? And that's kind of why everyone's going to planning now, because actually breaking things down to smaller things is actually better than wanting a 10 million context, 100 million context, or 1 billion context. So there are strategies that you can use with the technology we've got today. And if DeepSeek has taught us nothing else, they had less compute to do things, less powerful compute, and they came out with some very powerful paradigms on how to improve not only inference, but training of models to produce the outcomes that they produced that pretty much surprised the world. And that's because they had to be more creative because they were using what they had. And obviously, I think we tend to be a bit lazier that we just, I want to use the best model, I've got to use the best model, it's the best model. You don't need to do that if it's not necessarily required. And then basically all we have there is we just build up the message history, let it loop through until it's completed. Demo 1, done. Demo 2. Let's do function calling. So, oops. Well, function calling demo. So this one is basically a precursor to say I want to get a loan. So I want to check whether, how much money would you lend me? So this will gather information to go away, and it'll call up to 3 functions inside the conversational inference. In code, technically, it's outside of one traversal. But what it'll do is it'll go away and use function calling to go away and do 2 things to do with credit history. So it'll get do you pass their credit checks and what's your credit limit? And also it allows you a way to talk to a third-party telephony system to go away and schedule a call. So it'll ask you when you want to have a call, if you want to call. So first of all, it wants to know my name. So my name is John. So it knows it needs more than that. So I go Mr. Smith. I thought it would have figured that out. So what is my name? Let's ask it. My first name is John. I've already told you that. There we go. So it's figured it out. Usually it would figure it out itself, but never mind. Now it's asking me the address. So I'll just go, oh, on the street. It's my address. It knows it needs a full address, so it'll now ask me for a town. I'll give it a town. And then it'll say I need the postcode, so I'll give it a postcode. So it's now got the full address, and now it's telling me what it can do for me. So it told me at the start what it could do. It didn't actually mention the fact it could do a call for me, but I didn't actually tell it to sort of broadcast that. So if I wanted it to explicitly broadcast that, I would have told it, but generally you might not want it to do that. So I want to check credit history. Do I pass? So that'll go away. That's now calling the credit service, and it's calling the credit check, and we've passed. So we've passed the credit check. Do you want to carry on with anything else, or do you want to leave? What's my credit limit? This is a second function call on the credit service. It'll go away and get my credit limit. So it's going away making a call to that service now. And there we go. So it's £100,000. I want to speak to a human. Okay, what's the telephone number? Told it that. Now probably just asks me for the time. So 1600 today. It's going away calling the telephony service, and at that point, the call's been scheduled. So somebody will call me at that point, and we're now finished. So we'll just say goodbye. Boom. Again, we've got the conversational history there. Now, in this case, we may not use the conversational history. We may log it just because we want to log the conversational history, but it's actually done the functional things that we want it to do to the point it's already got us to speak to a human. Now, the human can already probably see that history because we can go away and stick that somewhere else in a database, for example. So that's that particular demo. So let's do the structured demo now. So let's say this is a bit further down in the loan application process. Now, I've saved a bit of time rather than me typing all the information. I've got, again, a very... oh, actually, let's go through the code of that before we move on. Let's go through the code of that. This is the function calling agent. So here we've got the beautifier and the experience manager as injected dependencies. I've also, in this case, actually doesn't use these here anymore. You'll see it's in the plugin, but I've injected the credit service and the telephony service. We build a kernel. The key difference here is we tell it it's got plugins, and you'll see when I show you the plugin how it manages to cross-correlate what those are, and then we just build the kernel, and then we create a chat completion service. So you can see here, I've got a system message, which is a bit more verbose. It could probably figure out the context of what the plugins can do, but I've given it a little bit of a description anyway to help it along the way, and then told it about what its core remit is. The only other thing then is that I've set in the execution settings of the conversation that I want function choice behavior to be automatic. So it will go away, and if there's thinks it wants to trigger a function, it will go away and do it. It's still my responsibility to go and invoke it, but it will go away and tell me that function calls are required and inject those into the conversation. You can do them manually. So for example, you can also do function calls yourself inside a conversation and just manually invoke them. There's nothing stopping you do that. There might be reasons you want to do that for a more complicated reason. You've got the capability to do that if you so require. So again, it's just a very much simple conversation. It invokes a chat at the point of exiting that chat. It has some information about whether it wants to do a function call, what those function calls are, and then obviously the framework here just provides a very easy wrapper for you not to have to write any code to invoke it. It works it out from the plugin name and the arguments to invoke it for you without you writing any code. In fact, this whole little segment here of 20 lines could be wrapped in its own little method, and you could actually get that to be transposable across any function calling application that's using semantic kernel. And then essentially it basically adds whatever comes out of the function call, the conversation history. So the model has context of it when it moves on to the next question from the user. But apart from that, that's essentially all that does. Not much more code than the original one. Pretty easy to do. So we got to about 30 minutes when we got there. So we'll now look at structured outputs. So again, I pre-programmed the conversation here. So I built a set of conversations so that I don't have to type it manually, because there's a bit more information here. 2 sentences, fair bit more information about a loan summary. Obviously, it's a very easy, simple demonstration, but you know, you can add more to this if it was a real application. So we've had that discussion. It's gone away. And I'll show you in a minute how it figures out what to do, but we've already set this up as a structured output emission, so it knows it's going to emit JSON, it knows what the contract is, and it'll go away and do it. So if I press enter now, what will happen is it'll process the conversation history, and you can think of this as maybe as part of an orchestration. It's come out of the conversation, it's going to a second agent now to do a structured output on the data from the conversation to give me JSON. So we'll do it. That's gone to the model, it's come back, that's the JSON. So if we set up the JSON schema to be analogous to an existing API endpoint we've got at this point, you could also go away and post it to the API, which may go into the database for us. So if there are issues with the JSON, we can have a validation agent, goes away and says, if there are issues with this, this, or this, go away and send it to a human, don't send it direct to the database. So again, you've got the power to do that. You don't need to write a lot of code to do that, but that's the whole point. You don't need to write a lot of code. So if we go and have a look at the code now for that example, just to dot the I's, cross the T's, very similar to what we had before. We build a kernel, we go away. The only thing we do here is we tell it the response format is type of loan summary. So if you've ever built any of these structured outputs, the actual JSON you have to build inside the API call. If you're building the raw API call, it's quite complicated. So each field can have a number of fields of different types, and if they're lists, they can be even more complicated. So semantic kernel actually go away and do this for you. All you need to do is say it's type of loan summary. And loan summary, if we go to the definition of that, I just whacked these in one file initially. I also gave them descriptions here, which may be useful to the model to figure out the context of it. So there's 3 classes, loan summary, borrower, and lender. It knows that. So what will happen now is that will go and process that conversation. I'll invoke the prompts. And at that point, what happens is it will come out. So actually, you should be able to just do this, result get value, and you should be able to put T in there, so loan summary, and it should marshal it out. In the current version I've got, there's some issue with that. It doesn't appear to be working quite right. So the easy response is get it out of string and then just do the deserialization yourself. In reality, it should be able to do that for you automatically. So really, that's structured outputs. For machine-to-machine outputs, it's very useful because you only ever want JSON, and sometimes models will deviate from their prompts, and you have to detect that they deviated. It wasn't JSON, it wasn't the JSON you expected. You have to make it go around again. So that structured output format very much makes that a much easier machine-to-machine experience. So they are very useful indeed. And finally, let's go multimodal. So I told you that I added voice. Let's zoom in a little bit. Got the real estate. So let's go to voice. So I've switched to voice mode. So the experience manager, none of the code is changing. The experience manager deals with the translation to a different type of experience. So we'll go to a chat experience. So let's fire it up. So obviously I won't really be able to, so this could be in WebRTC in a browser. This could be going to a telephony system that's calling this to either do the TTS itself. I'm doing the TTS in this case, but it's, it pays your money and takes your choice. So I won't be able to discuss much till the end of this because obviously it'll be waiting for me to say stuff. So let's crack on.
Hello. I believe you have a complaint. Tell me more.
I am very, very angry.
I'm sorry to hear that you're feeling this way. Can you please provide me with your name? Additionally, what is your delivery number? Lastly, could you share what specifically has caused your frustration?
My name is John Smith.
Thank you, John. Could you please provide your delivery number? And then, could you explain what the issue is that you're experiencing?
012345.
Thank you for that. Now, could you please describe what the issue is with your delivery?
Sorry, I got the delivery number wrong. It's actually 123456. Can you correct that for me?
No problem at all, John. I've noted the delivery number as 123456. Now, could you please explain what the issue is with your delivery?
My package was damaged in transit by the courier.
I'm really sorry to hear that your package was damaged during transit, John. Thank you for providing all the information. Is there anything else you would like to add regarding your complaint?
Yes, it was a very expensive dining room table, and one of the legs was severely damaged.
I understand how frustrating that must be, especially considering the value of the dining room table. Thank you for sharing this additional information. To summarize, your name is John Smith, your delivery number is 123,456, and your complaint is regarding a damaged dining room table with a severely damaged leg caused by the courier. This has been escalated, and you will be contacted regarding your issue. Is there anything else I can assist you with?
No, thank you. Goodbye.
Thank you for your patience, John. Goodbye. Conversation ended.
So there we go. That was that demonstration. So that was probably just giving you a bit of an idea of how easy it was for me in 10 minutes then to pivot the same code without making any changes to a multimodal demonstration. So this is the big thing about AI that is going to be the big thing. It's going to be about clever consumption using experienced and sort of exceptional individuals with that experience to understand where this is going, to be able to actually improve productivity, not through writing more code faster, but from writing less code more cleverly, consuming things that don't require you to maintain a lot of that code. So we went from 3 chat agents to, in fact, all 3 of them are now multimodal. So they've now all got voice capabilities. So on later demonstrations, I'll show you inside a UI, building that into a dynamic UI experience. It can pivot that into a dynamic UI. Why would you spend a year writing a UI for a very complicated loan application when essentially you don't do that via the voice? You don't spend a year building a script for somebody in a call center to do things. And also, if you then gathered all that loan information, what if you want to go away and get quotes from all different providers? You're not going to go away, and what you do traditionally, right, each one's got their own API and write code to go away and pivot to all those different APIs. You're going to see APIs are going to be becoming more considerate to AI by simplifying their implementation. And what you're going to see is you're going to see agent-to-agent calls, where actually what will happen is our agent would talk to another agent, which is the third party, without any code existing at all. Because why would you write all that code you've got to maintain and spend persons of years doing it? That's not where we're going here. So you need to look past the writing of code and think more about what's happening with what's going to happen with consumption. So again, I've called it right pretty much. If you go back over the past couple of years, pretty much everything that's happened I've called ahead of time. This is clearly where I've always seen it going, and I think it is going to go. And you can see it's going with some of the implementations in terms of these frameworks now. They're copying a lot of the concepts like planners to be able to go and break big tasks into smaller tasks. That's all happening because that's how you basically get more efficient use of models. And that's going to be the big thing is I'm not using the biggest model and it's spending all this money on this model. It's all about efficiency, cost, return on investment, because that money is the business's money and you need to look after it with care and attention. So that's what we're going to be seeing here. And I'll also show you with this demonstration later some cyber implications for some of these. So I'll show you a couple of interesting demonstrations which might open your eyes a little bit to some of the issues that we're going to be seeing with all these AI agents that not only are running in your stack, but are running in all the stacks of applications you're now using. And you may be talking to those stacks using MCP, opening up the scope of your stack to those stacks as well. So that's definitely going to be big news when it happens, when these start to be compromised. So that's something we'll have to start thinking about building in. People start to think about building in permissions. So things like Enter ID in Azure AI Foundry, for example, but people are also going to be starting thinking we need a little bit more than that. So we need in agentic flow security. So I'll show you some demonstrations that will probably crystallize why that's the case. So hopefully you've seen Microsoft Semantic Kernel. There's lots of frameworks for doing things. You can build your own. You can mix and match. You can mix your own orchestrators. You can mix and match models using your router or somebody else's routers. But basically, you want to use the thing that makes your life easiest to do the thing you need to do. So that's really what that demonstration is about today. So hopefully you got something out of that. Have a great rest of your day. Weather doesn't seem to be picking up here, but I'm going to go outside anyway. Look after yourself. Take care. I'll speak to you soon. Bye-bye for now. Bye-bye.